Hello there, welcome to my YouTube channel. So today I'm going to show you how to develop a HEC-RAS model from DEM data. If you don't have any surveyed geometry for your river or any channel, you don't have to be worried about that one anymore. So today I'm going to show you that how to create your geometry and even the HEC-RAS model if you have any DEM data. And if you don't know how to download this DEM data, I have already demonstrated that one in my previous videos. You can check my GIS tutorial series as well. So here it is. We are working on that tutorial on GIS. So here is the location, right? That location is over Houston City. So it is called San Jacinto Watershed or Basin. I'm working on this one for my GIS tutorial. So I'm gonna use this one to extract or to export the geometry for HEC-RAS model for any section of a river or canal or channel. So how can I do that? At first, we have to convert it. If you don't have any GIS software, you can even download it. I have already mentioned that one in my previous videos. You can download for free and you can install that cracked version as well. So I already demonstrated that one, how to install GIS software 10.8 version. And in order to do that, we'll use today the HEC-GeoRAS. The HEC-GeoRAS, it is nothing but, again, it is a HEC from Hydrologic Engineering Center. This software package you can download from this link. I'll give you the link in the description below, but this is only for GIS 10.2 version. But if your GIS is 10.8 or 10.5, so how can you do that? You have to have the same version of your HEC-GeoRAS and your GIS software package, then it will work. Otherwise it will give you a different error and you will not be able to generate anything. Okay, so I'll give you also that link. Here it is. Here I have the link. I'll give you this link and you can even download anything 10.2 to the latest version 10.8. So okay, since I'm gonna use the 10.8 version of ArcGIS and I have already demonstrated how to install that one in my previous videos, and you can install it for free and you can click there and you can even download from here, right? You can download it. Once you're done, you can just double click and next, it will install, and then you'll open ArcGIS if you already have. Then you can just right click here and you'll see a list of HEC-GeoRAS, right? So at the very beginning it will be like that and you have to click and then you can see it's there. Okay, before going to do that, we'll use different options from there. So at first I have to process my DEM data. So the DEM data I already projected it into, let me just show quickly if you don't watch my previous videos. It is called a state plane coordinate system, right? And the vertical unit is also in feet and the horizontal unit is also in feet. And I have the cell size 97.44 feet by 97.44 feet. So my DEM data, basically it has both vertical and horizontal unit as feet. Okay, so you can see on the lower right corner, the coordinate it is showing as feet as well. So at first I have to convert this DEM data because it is in T-pile, right? So usually DEM data, it has the .tif extension. So we have to convert it to TIN. Okay, so how can you do that? When you'll install the GIS software package for the first time, you have to click there, customize, and then extensions. And then you have to activate all of this 3D analyst, okay? And then all of this, then you'll have access to 3D analyst tool here. Once you can just activate this one, and then if you go to our toolbox, you can find it there, or you can even click there. Okay, so I have here. So now I'm gonna click on that. I'm gonna expand it. 3D analyst tool. I can see conversion. Okay, conversion. So since it is raster, I'm gonna convert from raster, right? From raster to TIN. If I double click there, you can see it is triangulated irregular network, TIN. So in order to export or generate geometry, or in order to use that HEC-GeoRAS software package, we have to convert the DEM into TIN. So here I'm gonna just input raster, it's DEM feed, the same name, it's there, and then I'll just convert it. So the main tip for this GIS software package is whenever you'll do something new, you should just create one separate folder and create one geodatabase, and then you can do everything there. Then you'll have access in future, and you can even send it to any other person. They will even able to do the same thing. So here's my default directory because I already created this directory inside my D drive, and that is the name HEC-RAS and GeoRAS, and then that will be the name of the TIN, okay, DEM feed raster to teen. And then if I click OK, then it's gonna convert pretty quickly. Let's see if I'm successful. Then it will show different color, and we'll work on that one. See, we're done with the generation of TIN. It's pretty simple, right? Okay, so I don't need DEM, so I'm gonna work only on that TIN. So I have many streams. Out of this one, I'm gonna select this simple straight one. So at the very first moment, I'm gonna quickly show you how to create that HECRAS model if you have any single stream, and then I'll show you how to connect the tributary and distributaries. Okay, for the first time, the first trial or first case, I'm gonna show you the simple one for a single reach of a river, this portion. Okay, only to demonstrate how to do that, and then I'll do it again including that part because we have different options there we have to do separately. So here it is. Now you have your HEC-GeoRAS activated and you have access to there, and click on that RAS geometry, and then we have to create different layers. Right here you can see the stream center line and bank lines and flow path center lines and cross-sectional cut lines. Stream center line is basically the line that will follow the deeper path of the river, means Tolweg. That is the stream center line. And then bank line is the bank of the river. And you can see here the white portion, that will be the bank. I'll show you how to do that. And then we'll use this flow path center line. It is also representing 3 different lines. The main line should be the channel, and we'll have 2 different flat planes. It is just now a little bit longer than bank, and then we'll have cross section. These are the cross section we need. So we'll do that. We'll do it 2 different ways, manually and then automatic. So in the first case, I'll show you manually, and then in the second case, I'll connect tributaries and distributaries, and then our length of the river will be long. That's why manual process will take time. So I'll use automatic one. Okay. So that's it. First, select stream center line that will represent river. Okay. So before that, what they're suggesting us to save the project, and before saving the GIS project, what you need to do, just use that store relative path name, then it will just store that way, and then it will be easy to open previous in future, and if you even send it to another person, they'll be able to send it. And then save as. Okay, save as your project there, not here. Just I'm going back to my HEC-GeoRAS. No, not is that one. So I have this one, HEC-RAS, GeoRAS. Inside that one, I'm gonna save my project. Okay, which by the name GeoRAS. Okay, GeoRAS. I'm saving it. And now if I click there, create RAS layer and stream center line, it's gonna show you the name of the river. Click just OK. Okay, this is created. It's showing the message, and then create bank lines. It's gonna create only the empty name, right? These are only name. We'll edit and we'll create that bank and river, everything. And here, flow path center lines. Yeah, just create that one. It's this, we have this, and you can even create that, create cross-sectional, okay, cut lines. We're done with this one. Okay, so what next? Here, click on river, and then if you don't have this editor, right click, and from here, just click editor, then you'll have access to editor here. And from editor, click start editing, and then it will show another window here. You can see your shape files, right? All these shape files, the lines, these are the line shape file. These are activated. So I'm gonna click on river because and you can see I'm gonna just generate lines, not rectangular, circle, ellipse, or anything. Okay, this should be line. I'm gonna zoom in. I'm just zooming in, and here I'm just selecting this one. Just draw a line following the center or the deeper part of your river or stream. That is the deeper because it's gonna represent that thalweg. Okay, I'm just doing it pretty quickly to show you how to do that. And mostly you'll see this watermark. So it is customary to follow that watermark. That is the thalweg, this one, right? This blue, light blue color you can see. That is the deeper line. And that's it. Okay, I can stop here, double click, and then I'm done. What you have to do, because I'll extend this one later on while I'll show you the tributaries and distributaries. I'm showing it in a manual process. So here, I'm just gonna stop editing and then save. Okay, yes. Then what you have to do, you have to click there, okay, assign river code and reach code to river. So if you just click on ID, then click on that river line, it's gonna ask you the name of the river. I'm gonna give this main river. Okay, if you have many, then you have to give the name of the river. Okay, I'm gonna give main river, and then I'm gonna give the risk name as creek. Okay, in USA we call it creek. If it is small stream, then it's creek. So I'm done with that one. Again, edit, and then this time I'm gonna edit bank line. So which one or which are the bank line? So for HEC-RAS model, you have to be able to identify the left bank and right bank. So since this river is flowing from upstream to downstream, that is the upstream and that is the downstream. So you have to look from upstream to downstream, and you have to look from this one to this direction. Then the left side, right? Left side of your, because you'll see the left side, right? It is the left bank, and the right side will be the right bank. So this is the left bank of this river, and that is the right bank of the river. So I'm gonna even start with the left bank. Follow this line, the white one, that is the flat plane. This will be our bank line, and I'm just doing it pretty quickly to show you how to do that. And after that, I'll finish off here. Okay, so I'm double clicking and I'm done. And here for the right bank, I have to do the same thing, and then we have to do the same thing for flow path, and then we have to assign the flow path as the left bank and right bank and the channel line. So then the code and the software package will understand that, okay, this is my channel, this is my left bank, this is my right bank, and then it will start calculating based on that. So I'm done with editing banks. Then I'm stopping, okay, saving this one. Now I have to go to edit again, and then this time it will be flow path. And for flow path, we'll have to draw 3 lines. One line following the river line, that will be the channel. Okay, so how can you do that? You can even click this way. So we have another easy step here. If you just click on trace and then click there, and if you just move your mouse, automatically it will trace. Okay, it's pretty amazing. Okay, and then I'm done, double click. So it's following the river line. And then I have to draw 2 different lines. So in order to do that, don't activate that trace again. Click on that straight segment, and then follow another line that will be away from. Let's create a little offset from the left bank and create that flow path. Okay, so for flow path, we'll have 3 different lines. One will follow the thalweg or the main stream, and another 2 that will be a little bit away from our bank line, because the software package will understand the bank line. At the same time, it will depend on the flow path. So I'm going to show you that one. So we are done with this. So stop editing, click yes. Okay, so here it is. We are done with assigning our stream ID, right? And then we are going to this one, select flow path and assign line type attribute. So if you click there, so it is showing 3 lines. The middle line, that will be the channel. So you have to click right on the middle line of the river line, and then as from the drop down menu, select channel. So okay, so that is, so we assigned, okay, this is my channel, and that one, click there, and that is the left bank, right? Assign that as left bank, and then assign that as right bank, and then it will understand, okay, I have channel, I have left bank, right bank. That means it will understand that, okay, I have the flow from upstream to downstream. So now it's time to generate our cross-sectional cut line, right? So we have to do the same thing if you do the manual way, and after that I'll show you the automatic way. And here, start editing. This time I'm gonna click on cross-section axis cut line, and then you have to remember that everything should be from left to right, from left bank to right bank, and cross section should be perpendicular to the main channel. So this is the left bank, you have to, and it should cross every line. Okay, every line. So here from left to right, double click, finish, and then from left to right, and you can do as many you want, and double click. Okay, and then here is another one, just double click, and then double click, and then I'm gonna finish off here. I'm done with this. Okay, and then I'm gonna stop editing, saving it one more time. So I'm done. Now what I have to do, I have to start the processing, the remaining processing I need. Here, go to RAS geometry, and then we're done with creating RAS layers, right? Then here, stream centerline attribute. You can click one by one, or you can click all. It will do this processing topology, length, and stations from one station to another one, and then elevation. It will do everything. Then I'm clicking all if everything is okay. So see, the stream centerline is the river, right? The river we edited, and then it will take the information from this train, that TIN, and then it will give the name as river 3D because it will have three-dimensional data, right? Or you can change this name as your wish. That is not a problem. I'm just giving it as it is. Clicking OK. If everything is okay, it will show you successfully done. So we're done, right? So we have the most important part now, that is that cross-sectional cut line attribute. You can even start one by one, or you can even click all to do all this processing. Again, you have to assign your river center line, that is the river, and bank line. See, here it is using the bank line. And then flow path, here is the flow path. We have 3 lines, and cross-sectional cut lines, we already have that cross-sectional cut lines, right? And it will also use that TIN, and it will give you this name, 3D, cross-sectional cut line 3D. And now if everything is okay, then it will work. Otherwise, so it's done. Okay, so process is done. Now we can see the cross section. If you click there, if you want to see the plot of the cross section, just click there and then click on any section you see. We have the cross section, right? And we can see the same cross section while importing this into our HEC-RAS model. See, we have this cross section. So we are done with generating our cross section and our bank line, everything. And if you want, we have other options as well. You can even generate Manning's roughness from here. And in order to do that, we have to have land use information, and you have to have that table, and then you can assign that one. So we can do it easily in our HEC-RAS interface, right? We can do that. And if you can even create that levies and other thing in future tutorial, I'll show that how to do that. And breeze and other structure, I already have demonstrated this one, how to import breeze and how to calculate breeze score. I already have that video. If you want, you can watch that. And I'm done with that one. So now it's time to export RAS data. Okay, so click on that, export RAS data, and see here it is gonna show you the same default, right? That default directory we have, and you can even change the directory if you wish. I'm not gonna change it because that's why I generated or created new, right, a new folder, and I'm just saving everything there. If I click OK and if everything is okay, then it will show that it exported successfully. Okay, and then we can see it's done. And now we're done with this one. So what I'm gonna do, I'm gonna even show you how to import this into our HEC-RAS model. So in order to do that, we have to create a new project, and I'm gonna direct to that folder as well. And here is the folder GIS, and that should be HEC-RAS, HEC-GeoRAS. Inside that one, I'm gonna give this name as HEC-RAS, okay? HEC or HEC-GeoRAS, HEC-GeoRAS new creek. That is the name of the creek. And then I'm clicking OK. So it's gonna show you, okay, what will be the unit. For this case, it will be US customary unit. Okay, we have that unit because US customary means it is in feet. And now what you have to do, you have to open that geometry, and then you have to go to file, and then because the geometry we generated, it is the GIS format, right? So GIS format, and then see, it will show you this SDF file. If you select that one and then click OK, so it's gonna ask you again what is the unit of that file. It is also US customary unit, right? And if you click next and then click next, and it's gonna show you everything, the cross section number, everything, and then finished import data. So see, here you can see we have that geometry, and that is the office stream, and it is going to show the flow direction, right? And if you want to see the cross section here, we have the cross section. See, we have the cross section, and you can see one by one. You can see every cross section if you want, see, and you can do the processing. So this is how, if you have any one single stream or channel, and if you have very accurate DEM data, you don't need to just hire any survey company to survey your entire river. That is pretty costly, right? And I already demonstrated how to import survey data to generate geometry for HEC-RAS model in my other videos. If you want, you can watch that as well. So I'm done with this one, and if I want to even run the model, I can assign my condition, right? And now, since I just imported it, I have to even save it, right? I have to save the geometry data. So I'll do that after generating another set of data from this same DEM. That's what I need. So I'm just done with generating the simple one. Okay, I'm closing this one, okay, and finishing this one. So here it is. Now I'm gonna extend it, and I'm gonna consider, then I'll run the model. So I'll consider this tributary, right? Okay, I'm considering this one as my main channel, and I'll start from this one. It will be pretty long, and I'll stop here, and I'll consider this one as my branch. Then that is the reality, and if you want, you can add this one. So I'm just trying for another one. So in order to do that, I'm gonna delete or remove everything I have here, okay? And now what I have to do, I have to do the processing, and this time I'll use my automatic delineation of cross section. That will reduce our time. But for stream center line, it will, because since we already have that, so it is asking if it is gonna remove or not. Okay, remove it and rename the same thing. We have the river, we have to do the same thing, bank lines, it's gonna ask the same thing, clear, and generate another one, because I'm doing the same thing on the same, right, file or folder. Then flow path center line, okay, remove and create another one. And finally, I have to do that cross-sectional cut lines. Okay, and clear and generate that. Now I'm done. So I'm gonna zoom in, because this time it will be pretty accurate. Okay, so that's why I'll zoom in and zoom out all time. Here it is, start, but you have to follow specific rule here. Okay, start editing and then create feature, that will be river, and I'm following this line from here. Okay, this one. So this time I'm just doing it pretty seriously, because I'll run the model, and I'll run the model not for actual data. I'll just run the model because I already demonstrated how to generate 100-year, 50-year, and 25-year of flood event, and I have done everything in my previous videos. You have to go back and you have to check how to do that, and for this time, I'll only show you how to run the model, if it works or not. Okay, if it's gonna work or not, then you'll see that everything is possible. If you don't have any geometry data, you can even create one, and if you have your survey data, you can use that one as well. So here it is. I'm trying to follow the thalloeg, the deeper line, right, for concave bank, because this is pretty meandering creek and it's pretty long, so you have to follow that. You'll have the deeper line, or the depth is deeper, right, where in the outer bank, right, and then you'll have shallow depth in the inner bank. And I'm almost done. So here's the thing you have to remember when you will have the confluence. That's why I'm just waiting to show you that. Here we have pretty accurate depth of the river. I'm still following. So here it is. We have to finish. I can continue. See, the main channel is going this way, but I'm not gonna do that because we have the confluence, and the model on the software should know that, right? We have to inform the software that, okay, this is my confluence here, so I'm gonna stop, right? I'm gonna double click and stop. And now, at first, I'm gonna just finish off with my main channel, then I'll start with bank line. Okay, so here it is. I'm just starting from this segment. So here it is, channel for this one, because you have to specify the junction, otherwise the model won't understand that. That's why we have to do it part by part, and we have to specify, okay, this is my junction. So how can you do that? That's why I'm just doing it once again, because you may have this type of issue in your real world modeling. If you have only one straight segment of a river, then you can follow only that simple step, or if you have complex river network, then you have to follow this one as well. Yeah, I could do that in a single video, but I'm just making it separate so that you can understand for two different cases. What I'll do, I have to select this point. Okay, how can I do that? I'm not, because it is already selected, right? It's already selected, but I have to right click and then snap to feature and then select the vertex. Then it will automatically select, right? It will select the vertex, and it's pretty accurate. Then you have to finish HEC-RAS. Then we are done with this one. So we have two different segments of stream. So that is the confluence. Now I have to start from this one. How can I do that? Just right click and then selecting vertex. It is gonna start from this one. Now we have the second, or the downstream part of our main channel. Okay, so follow this blue line, that is the deeper part of a river, and follow it. So that's why it is necessary to see all these steps. So in order to get that vertex, what you have to do, you have to just turn on your snapping tool. If you just turn on the snapping tool, then it will automatically show you that options you need. So still following this one. So this is kind of a real world case. That's why. So how to download DEM data, how to project DEM data. I have all this information in my GIS tutorial. You can see I have a lot of videos there, and you can even download that GIS software for free, because this software is not free for all, but I have the crack version and I have already uploaded this one for you so that you can practice more and you can learn more. So I'm gonna finish off here because it is all the same, right? If I can continue, because I don't have anything, so I'm gonna finish off here before getting another branch. So double click and it's done. Okay, so I'm gonna save this, and then we have 3 different segments. See, it's pretty big area, right? Pretty big. It's kind of real world case. So edit and then stop editing. I'm gonna save it, and now it's time to assign our river ID. Click that river ID and click on that one. So this will be our main, right? Main river. main river, and that will be the upstream reach. Upstream reach. I'm just giving this way, upstream reach, and that is separate from other part. So that is the tributary. So before going to do that, I'm clicking there. Oh, wait, so you have to click exactly on the river. Okay, then it's gonna select. So select that main river, that is downstream reach. If you have the name of the river or segment of the river, because if you have a big river, then it has different reach, different segment of a river. Usually people call it in a different name. So I'm done with first part, second part, and then we have this tributary. I'm gonna click on that, and it is different one. Okay, it's tributary. Tributary. Okay, and then that is the reach or creek, a new creek or anything. Okay, there is the creek. Okay, so now we are done with 3 segments of our streams. That is the upstream of my main channel or main river. That is the downstream from the confluence, and we have another tributary. Okay, so we'll run the model. So we'll have one flow rate here. We'll just assign a specific flow rate and another flow rate there, and we'll have a water level boundary condition there, and we'll run the model, and we'll see if we have any problem or not. Definitely will be successful. Okay, so we're done with assigning this one. Now okay, I already saved that, so start editing again, and this time it will be banks, right? Okay, it's gonna be the bank. So for bank, you have to follow the same rule, same thing. See, we have pretty big segment of the river. I'm gonna zoom in. That's why it's gonna take a while. So follow that line pretty quickly, and then we have to, that's why you have to follow this specific guideline to be successful. And here it is. Just follow this white line, because that is the floodplain for sure. That's why we need to generate, because in the DEM data we even can't identify. That's why we need that triangulated irregular network to identify our bed level or bathymetry data. So to survey this length of a river, it will cost a lot. So we don't need that anymore, because people are trying to generate this topographic data set from different sources. So LiDAR data is the most accurate data, and it has like less than 1 meter resolution, but this data, it has 97.44 feet or almost 30 meter resolution. And we also had that, I could download that one 10 meter, but I didn't, because it will just take a lot of time. I already mentioned that in my previous videos, and I already provided the link. If you want, you can do that. So I'm going to finish up here, see, because that is the bank of my upstream reach of the main river. Double click, and I'm done. Okay, and then I'm gonna even do that is the left bank. You already have idea about left bank, so we have to even assign the left and right bank separately. So I'm gonna do the same thing for the right bank as well. And that is why, see, so I'm following, even though it has different tributaries and distributaries, but I'm not gonna consider that one today, because it will take a lot of time. And even I'm gonna make it simple as possible. Here it is. If you have high resolution data, because the LiDAR data that I was talking about, it is basically, you can find like 1 meter resolution for some part of US, and then you can even use that, because I already used that in my other model, Delta model for flood modeling, that needs very specific or very high resolution data to resolve small streams. But for HECRAS model, if you just want to run the model for breeze scouring or any other thing, you don't need that high resolution data. But if you have, then it's good. And see, I have to even stop here, because I'm done with the upstream part of my right bank. Double click, and I'm done. And now I have to do the same thing for that stream, right? So that is what we are gonna do right now. So okay, for the right bank, because still now it doesn't have any idea about left bank or right bank unless I assign it. Okay, so that's why it doesn't matter if I start this way or that way. When I'll assign, okay, that is my left flow path line, that is the right, then it will understand, okay, this is my left bank and this is my right bank. Here it is. See, again you have to use the same thing. When it is just snapping, right click, snap to feature, vertex, right? And then other than double clicking, right click and finish scale. So we have that. Again, start from there. So this is how, this is sometimes time consuming and laborious you may feel, and sometimes it may even work if you just try to export, if you try to even use automatic. So you need to have patience and you have to do the same thing over and over. But the good news is that if you have problem while doing all this processing, then you'll learn new thing. So I'm gonna finish off here, right? Double click and finish. And now I'm gonna start from this one. So what I have to do, I have to select the vertex, right click, snap to vertex, and then it's gonna select vertex because that is the right bank of my downstream segment, right, of the main channel. So here it is. I'm pretty quickly digitizing that right bank of the lower part of my main channel and zoom out because it is not gonna be very long, right? Yeah. So in this window I can finish off. So here it is. Just follow this white line as you can, but you have to even capture all this bend pretty smoothly, right? I'm done. And now I have to do the same processing there. Click there, right click, snap to right vertex. We have the vertex, and then follow the bank of the river pretty quickly. But for your actual research or any project, just do it pretty carefully, otherwise your simulation may be wrong or maybe there will be some error. And if you do the same thing over and over, then you'll have experience on that and you'll know how to solve the problem. So now I'm done with the bank line, and then see, stop editing. I'm done with that one. Now it's time to start editing that flow path, right? So flow path, so clicking there, and now what I have to do, I have to even do the same thing for the channel, right? So in order to do that, I'm going to activate that trace, the trace, because I'm going to trace my main channel, right? This way, this way. It's pretty simple. I'm going to trace that, and then okay, it is pretty long. I have to zoom in, and then okay, so I'm here following this one. I'm gonna stop here. Okay, double clicking and I'm gonna stop. Yes. And then what you have to do, you have to do the same thing for this one. You can follow and you can trace it there. Okay, just follow this one and then trace it. And when you are done, just here, double click. Okay, so we're done. And then again select. Okay, we selected. Then we are just tracing, and then we're done here, right? Double click. So we're done with our channel. Then, because this is flow path, so we have to do the same thing for, so I'm gonna turn it off, and then straight segment, I'm turning that on. And here it is. Just follow this previous rule I mentioned. For the left bank and right bank, this is the flow path. That should be pretty close to our bank line, so that our cross section, automatic cross section, will follow this line, because that will consider this line pretty close to our bank. Even what you can do, you can even superimpose your flow path line over your left or right bank, but that is not customary. People, don't suggest that one. And then you can use your trace tool to just quickly follow along, right? Generate your flow path, because in order to use that trace tool, you need to have the line right beforehand, then it will follow any line, any shapefile or anything. And if you have your bank line already digitized for any region, then you can use those. I'm gonna finish off here, okay, because I'll use the bank flow path line for the tributary. Okay, I'm gonna start here, right? So this is the, see, in order to exclude any survey company to survey the river, we can take this hassle, right? Okay, see, I made a mistake here. So what I have to do, I have to delete it because it shouldn't touch that line, okay? It shouldn't touch the line. There is no way. Okay, Control Z, because that already selected. Okay, I'm gonna just delete this case, okay? This one. So I'm gonna start off here, starting over and then following that. So you have to be very careful and zoom in each time so that you can even follow the line and make an offset. Just maintain this distance so that it can't touch, and you can even change the snapping distance, the pixel. That is also possible. You can go to snap tool and then you can change that, then it won't touch. So it is just checking the distance between these two lines, and then it's automatically selecting the nearest point. So that was the mistake, but that is also useful to identify your ending point or starting point. So that's it, and that is the right flow path line for the upstream of my main river or channel. So here I'm gonna finish off. So that is done up to there, okay? Double clicking, here it is. Now I'm gonna do the same thing for this part and starting from this one, okay? So here it is, and I'll do the same thing that I have done for channel, for bank. So this is the protocol you have to maintain here. Let's right click, find the vertex and right click and finish its case. Okay, and here for the left bank, the flow path will follow the left bank and just follow this way and maintain an offset, uniform offset, and smoothly just try to cover every bend and then finish off here, okay? Double click, and that is the flow path for the tributary. Now we have to do the same thing for this one. So right click and find the vertex. So this is how that is just making it separate, right? Because the software package will understand that you have different reach of your river, otherwise it will consider only one, and you won't be able to even assign different flow condition, different name, because that is the rule you have to follow. And if you just practice several times, you can even remember every processing. And I'm gonna finish off here. Okay, double click and done. Now I'm gonna select this point, just right click, snap and vertex, zooming in, and then just following this line, and then we'll use our automatic. Sometimes it is, I don't know, but it may be going to show some error. Then we have to even remove all these errors, and you need to know. That's why I'm just showing separately. Otherwise the previous one, pretty simple, right? It was only for a segment of a river, and I'm done. Okay, what I have to do now, I have to just edit and stop editing, and then I'm gonna save it. Okay, I'm done that, and then you can save the project as well. Okay, now it's time to assign which one is our channel, which one is our bank or stream, right? So click there, select flow path and assign line type. So that one, zoom in, that is, see here, that is the channel. That is the channel, right? And that is the left bank, right? Consider that that is the left bank, and here it is the right bank, right? Yeah. See, when I'm clicking there, see, it is not selecting everything, right? It's selecting only the part, see, only part of the segment. So that's why we divided it, okay? So that is the channel. That is, I'm selecting the flow path. That is the left bank, and that is the right bank. And now we have to select the down, see, there is the main channel, and that is the left bank for that one, and that is the right. Okay, see, it didn't touch that, so that is the right flow path or bank. Okay, so now we are done with everything. We assigned our stream ID, we assigned our channel types and the line types. Everything is done. Now go to geometry, and then there, stream external line attribute, and click all. If everything is okay, so it's gonna give you everything. Okay, previously we have this river 3D, it's gonna clear first, and then it's gonna save everything successfully. Okay, it's done. But before doing that, what do we have to do? Before doing that, we should do our cross section, right? It's the time to generate the cross section here. If you click there, cross section, construct cross section cut lines, so here it is. Okay, so before doing that, what do you have to do? You have to measure the width of the river. So that's why you have to assign the width, right? What will be the width of the cross section, and then what will be the interval of the cross sections. How can you measure that? Since you're using GIS, go to there, the ruler, and you can select there as the distance as feet. By default it is feet, and then you can select there, or the maximum distance could be this feet, 15, right? Or 1600 feet. The width of the river could be 1600 feet. Okay, then we can do that. So again, click there. I'm gonna just showing you the entire view of the study area, and then clicking there, and that is the cross-section cut lines, and we have the river as center line, and the interval should be 1000, and then this should be 1600. Okay, 1600, or you can use 2000, whatever it is, but this is the way. And then the cross rule of the thing, the rule is your cross section shouldn't be cross, right? It shouldn't touch any other cross section. That's why you have to use a fair amount of length. So if I use this one, it's gonna show you the interval. See, we have this cross section. It's just a matter of one click, but see, we have some problem there. Can you see that? These are the problems we have here. See, this is crossing in a separate way, so we shouldn't do that. How can we remove? So we can edit. So that is the cross-sectional cut line. We can start editing that one, and then it will be cross-sectional cut line, this one. I'm just selecting this one, okay? And then you can even delete. You can click there, and you can select it, even you can delete it. And you can select this one. I'm gonna delete it. I'm gonna delete this one because these are not accurate one, okay? So this is the demerit of using this one. So if I select this one, I can even drag and I can fix it, but this one I can even okay, let's try with this one maybe. Yeah, this is good, but let's try to fix this one. See, now this is not touching. Okay, but what is this one? Okay, you have to even cover these lines, and then okay, check. These are the error you have to fix manually. And if it is necessary, you can delete this one. You can just replace the location, and you can even delete this one as well, this one as well, and fix the coverage. Okay, and if it is necessary, we can even delete other. Okay, we have a little problem there, right? So these are the correction you have to take care by dragging, and that's why I checked the length. Okay, the length of the river, this one. I'm gonna delete this one. It's gonna touch every line. This one I have to save. So it's better sometimes if your study area is not that big, and if your length of the river is not that long, you can just use manual process. That is pretty simple, right, and useful from my understanding. See, for any straight river, and if you have bend, so we have the problem in the bend here because it's trying to generate the cross section following that perpendicular line, but sometimes it can't identify, the algorithm can't do that. I'm gonna delete that. Okay, the rule is it has to cover every line, especially that flow path line, then it will generate the cross section, otherwise it won't. So here we have some massacre. I'm gonna delete this line and this line as well, otherwise everything looks pretty. Maybe this one as well. Okay, I don't know if it is gonna cover. Maybe no, it's not gonna cover. Okay, I'm gonna delete this one. Okay, so it's okay, this one is okay, and we have trouble there. I'm gonna delete this one and this one as well, and of course this one. Let's try to fix this one if it is possible. Okay, let's try to fix one more time. Maybe I'm gonna delete this one. And okay, so this is one way to fix, and we have seen different issues here. Maybe I have to delete many, so I'm dragging there. I'm gonna delete this one. I'm gonna select this one and delete, and for this one I'm dragging and fixing the length. We have to delete this one or try to fix it. Maybe it's gonna cover or not, I'm not sure. Maybe yeah, it's okay. So here it is. I'm gonna delete, and I'm gonna try to fix this one as well. It's okay, this is okay. Maybe this is not okay, I have to delete that one. Maybe this is not okay, we have to delete this one as well. And here it is. Maybe we can try to fix that. This is okay, so this could be also okay. If I just drag it a little bit, maybe this is also good. Okay, so we are almost done, and we can even insert if we want some other stations. I'm not gonna do that right now, and you can even insert other stations, and I'm not sure if it's gonna work or not, right? So these are the problem we have to do. You have to follow that no two cross section. Okay, two cross sections are not allowed to cross or touch, but it has to even cross this flow path, and then you'll be done. So we have to do the processing one more time. So here topology and everything all, and then again it is gonna do the same thing. Successfully it's done. The most important and problematic part is this one. If everything is okay, then it's gonna create everything. So river, bank, flow path, cross-sectional cut line, DEM, and then it's gonna be this one. Okay, and let's see if everything is okay, then it's gonna create. Maybe hopefully it's gonna work. See, it worked. So we are successful, right? So what we have to do, we have to go to our export RAS data, and by default it is there. If I click OK, so it will replace the previous one. Okay, I want that. See, if it is successful, sometimes everything is okay, and after that, while exporting this one, it may not be successful. That's why you need to create a separate folder. This time we are done. Okay, we're lucky. So I'm gonna save this, and I'm done. Now let's try to finish off my HEC-RAS project. We are done with our new. Okay, so now I'm just gonna replace this one because it is not gonna exist anymore. And GIS data, okay, this one, and hopefully this is gonna be this one, right? Clicking OK, customary, and everything should be okay, finished. Let's see, we have this one, right? So we also have our previous one, so I'm gonna remove this one, and even if it is necessary, I'm gonna even open a new project. Okay, new project, and I'm not gonna save it. And Okay, it's gonna open. No, I'm not gonna open that. Okay, I'm not gonna open that. I'm gonna create a new project, create new project. Do you want to save? No. And then the project name should be a little bit different than just creek. Okay, tributary, main river, main river, and then it's okay. We have this, and then open the geometry, and then I'll use a default value or some value or any arbitrary value of my flow condition, and then I'll run it for a steady condition. And you can run, because I have the previous tutorial how to run the model for steady condition and unsteady condition as well, right? So GIS format, this is one we need, and here it is, finish. Okay, we have, see, it's pretty simple, right? And it looks good. We have the flow direction, main river, see, it's even giving you the name, and that is the flow direction, and that is the tributary flow direction, there's the main channel downstream. So that is the office stream. You can check the cross section, right? The first cross section, and you can select main river, you can select tributary. It's gonna show you that way, this way. You can check if your cross sections are okay or not, and even you can interpolate between cross section as well. That is the main river, and you can check, even see many cross sections. So if you have longer length, and if you select the downstream, it's gonna show the downstream. See, this one and this one. So the number 1000, it is the downstream cross section where we'll have our water level boundary, right? Water level boundary, and here the 58000, that is the office stream of our main river, and we have 15,000, right? That is the office stream of our tributary. So we'll use that information. So I'm gonna save my geometry, save geometry as, because we just imported the geometry, but we have to save it, geometry. Okay, geometry, and then it's there. Now what we have to do, we have to even generate our steady flow condition. Go to edit, and then as before, because I have already demonstrated that one, right? So edit steady flow data. So here we can see we have that office stream section here, right? We can even import, that will be our 10,000, okay? 10,000 CFS, and we have main river, right? Downstream. We don't need anything but tributary, the 15,000, that is the office stream, right? We also have like 5,000 here. And here, the downstream part, you can even use another one. That is kind of 3,000, okay? We have 3,000 CFS, we're done. Then this is the flow, like for example, if you have your 100-year flat plane, you can do that, right? I already demonstrated that one, 100-year, 50-year, and 25-year, how to do that, how to generate, how to change the name, right? Edit profile name. I already did it. For example, this is 100-year, okay? This is 100-year of flow rate data. And now we have to even assign our downstream boundary condition. The downstream boundary condition will be water level. I'm gonna just assign any specific data. So how to do that, right? If you need to change anything, you can do that. And here, click on that, reach boundary condition. And here we have this junction. See, this is the junction number 2. So we have to assign these values there. And we have our non-water level, okay? Non-water level. We have the junction, this is junction 2 there, and here main downstream there, we have to assign at the very last moment. So the non-water level, that is the water level I'm gonna give. For example, I have the water level as like 15 feet, okay? And that's it. I don't know, but I'm just assigning this value. Let's see if I'm okay or not, because I don't have any idea. I'm just giving arbitrary to run the model. So I'm done with that one. I have to save the flow data, right? Save flow data. So this is basically flow, okay, steady flow. Steady flow, because I'm just assigning one. Steady flow means if the flow condition, like flow rate, water level, or velocity remains constant with respect to time, then the flow will be steady. Otherwise, it will be unsteady flow. If the water level, flow rate right, change with respect to time, then that is called unsteady flow. For example, if you have a time series data for 1 month or for 1 year and you are going to run the model, then you'll have to assign unsteady flow. And I already demonstrated that one, how to generate flow condition that is steady or unsteady, whatever it is, in my previous videos. You can check that. And I'm done with that flow condition, right? I'm going to close that. Now I have to go to run and then steady flow analysis. And here, right, it will be subcritical flow, and then you have to assign your geometry there if you have, because I already demonstrated how to select different alternative flat planes in my previous videos. I can use different geometries, different breeze condition, different PR condition. So I'm already done with this one. If you are interested, you can go back and check. So here I'm just running for the condition that I have, right? The main objective of this tutorial is to generate the cross-sectional data from DEM. Others are not optional. That's why I'm not going to change any condition there. So what I have to do, I have to save the plan. Okay, save the plan, just run one, and I have to give the condition as like okay, plan 1. Okay, plan 1. Then if I hit, but before that I can even use that flow distribution locations there as 8 and here as 8, then we can see the velocity profile separately. So I'm just saving the plan again. If I run and if everything is okay, then it is going to run. Okay, otherwise it's going to show this error, that error. You have to solve this error. What is, oh, we don't have the Manning's value, right? See, that is the problem, because we didn't assign the Manning's value. So in my geometry, what we have to do here, we have to assign the Manning's value, and we already have idea how to assign Manning's value, right? So you have to go to tools or tables there and Manning's value and select this. Okay, select the main river, first main river, and or you can select all the reach you want and select the values, this one. Okay, and then it's gonna select everything. So set the value, that will be 0.0 for example 35, okay, or 25. I'm just gonna assign the default value, and this one, this should be for the middle, I mean the main channel. So that should be 0.0 because that is pretty smooth and bank is pretty rough. That is going to be 0.020, and then I have this for the right bank, that is going to be 0.03 or 0.025, right? Same for left and right bank. So I'm done with everything. Okay, just save, and if you want to check it, you can check. See, now it's populated with Manning's roughness, and it's gonna see for every section we have the same value. Now I have to save the geometry one more time, and then I have to run it. If everything is okay, then it's gonna run, otherwise it's gonna show another error. Let's see, we have creek, no Manning's, I haven't specified the Manning's roughness for the tributary. Okay, so we have to select upstream. I'm done with upstream. I have to do the same thing for downstream of the main channel. We are done with that one, but for tributary we have to select it separately, and I have to assign the same value, 0.025. So this is good that, okay, if you have any error, it will give you the error, and then you can read it, and you can, there will be 0.020, and you can fix it. So that is the tool. You can even assign the default value is pretty quickly, 0.025 for the right bank as well. So we are done with this one, and then I'm gonna save that again, and then this time I'm hoping it's gonna run. Okay, let's see. Yeah, it's gonna run. See, we're pretty successful, right? It's pretty amazing that, okay, we started the model from our DEM data, while I think it didn't take that much time from the HEC-RAS. I just generated the model from HEC-RAS, right? And let's see the results. Okay, if I click there, you can see the result. The flow condition, because the flow condition I use, it is not that high, that's why it's this one. Okay, this one, and okay, one more time I'm gonna change the flow condition to show you that, so that you can understand. So instead of 10,000, I'm gonna use like 30,000, okay? And instead of 3,000, I'm gonna use that as 10,000, and instead of 5,000, I'm gonna use that as 20,000, okay? And let's see, apply data, and the downstream boundary condition, that should be non-water level but not, so that should be 25. And let's see, now we'll have definitely higher flow rate and everything, saving this flow data, okay? And I'm gonna run the model because we are done with model run. Now I'm gonna run it. See, this time you'll see higher flow rate and everything there. See, it's gonna give you this one, okay? So that is the flow you can see here. And if you wanna even see everything from the main window, you can even check that here. You can see there the velocity distribution here. See, we have the velocity 7 feet per second. So this is how we can even specify, right? How do, because I already demonstrated that one in my previous videos, how to calculate that flow condition, right? For 100 year 50, you can check that. And I just demonstrated this one only for the sake of running this model. Okay, and if you want to even see the 3-dimensional flow profile, you can even check that one as well. From here you can see the long profile here, and if you can, because I already have demonstrated this one for different flow conditions. And here from view perspective plot, you can see the perspective plot this way, right? You can, this is from upstream or downstream, and you can even change anything, okay? We can even start from beginning to the end, and okay. And if you want to even select different values, for example cross section, and if you select the main river and upstream reach, or okay, upstream reach, then you can see from the perspective plot it's gonna show that one as well. So 3D perspective plot, see, this is for upstream, you can see that, and you can even rotate that one, right? These are the thing we already have done previously. You can see, you can rotate it, you can see that. Okay, these are the, see, we have a drop of water level because that is pretty sharp, right? And we can interpolate. I already demonstrated that one in my previous videos. If you need to interpolate in between two sections, or even interpolate between or in a within a reach, then it is possible to do that. Okay, so that's it. I'm not gonna even take more time to make it longer. So that's it. If you have any DEM data, you can use HEC-GeoRAS to develop your HECRAS model, and then you're done. And you can even insert any breeze in right anywhere if you want. So that's it. So I'm gonna finish up here, and if you have any query or question, I'll give you the link in the description below how to download that HEC-GeoRAS for any version of your GIS software package, right? And then you can practice by yourself. And that's it. Thank you very much for watching, and thank you for supporting my YouTube channel. And if you have any query, you can, or any suggestion, you can provide that one. Or if you have any requirement, or if you even wanna ask that, okay, if I need to show this thing or that thing in my future videos, you can, yeah, you are welcome to mention that one as well, because other people have already mentioned that one, and based on that necessity, I already created some videos and uploaded that one, because I can't help an individual student one by one, but I'll try to generate videos so that other people, or many people, they can be benefited from this one. So thank you very much once again, and stay safe. Bye.